Okay guys, this is your second homework. So I'm just going to go through these questions now. You printed off the sheet or downloaded it, but you can zoom in on mine. Look what I found in the SLT stationery cupboard yesterday. Obviously, help myself to them. Beautiful. Okay, red or green. Let's see what the green's like. Oh, beautiful. I think I'll go with red for today. Okay, I've got my calculator. Yep, put that there. So the first one. So let's have a look at this one. Sunday's question: a particle P, a mass of 2 kilograms, is moving under the action of F newtons. The velocity of P is. So you can do this a couple of ways. Actually, you can simply just look at the velocity at one point in time, which is 2I minus 5j meters per second. Okay, and that's at time t is equal to 0, so we could even call that u, couldn't we? It's the initial velocity here. And then after 5 seconds later, it's travelling at 7I plus 10j. That's what it's doing 5 seconds later. So you can see that in this 5 second, this is the velocity after 5 seconds. Let's put that. You can see that in this 5 second gap, the velocity has changed from 2I minus 5j to 7I plus 10j. So 2I to 7I is changed by 5I minus 5 to 10j is 15j, isn't it? It's changed by that in 5 seconds. Okay, that's what the velocity has changed in 5 seconds. So if we divide that by 5, we get I plus 3j in 1 second. And of course, the way that the velocity is changing per every second is the acceleration. So that's the acceleration. The acceleration is I plus 3j meters per second. Okay, squared. Okay, so there's your acceleration. Another way of doing it is to use Newton's formula. The velocity is equal to the initial velocity plus the acceleration times time. V equals u plus at. The velocity is 7I plus 10j after an initial velocity, that's u, of 2I minus 5j, plus the acceleration, which we don't know, but we know that the time is 5, so 5 times a. Okay, so there we go, just sticking these vectors into v equals u plus at. Then if we take 2I minus 5j off both sides, of course, we get that 5I plus 15j is equal to 5a, and divide by both sides by 5. Okay? And it gives us this. So that's the first one. The vector f in the form of ai plus bj. Okay, so you simply know that f equals ma. So this is part b, this is part a. So f equals ma. And of course, what are we doing? The force. Yeah, the force then is equal to the mass. Now you read the question, it tells us that the mass is 2 kilograms, and we've just worked out the acceleration. So there you go. It's as easy as that, isn't it? There's F is equal to the mass times the acceleration. So it's just 2 times that. So the force is 2I plus 6j. And that, of course, let's put the units for that. That's newtons. So 2I plus 6j newtons. And some of you may struggle with this one. The value of t when p is moving parallel to I. Okay, so well, you can see here that because of the acceleration, the velocity is changing. And you can see that this is actually changing direction. Remember, acceleration is not just the change of speed in time, but, well, it is just a change of speed in time, but that speed, you know, if it's if you get that acceleration effect, if it's sort of rotating around or going on a curve like that, you feel it, don't you? Because either the north or the east bit is changing of the acceleration, okay, of the velocity. So the value of t when p is moving parallel to I. So if we go back to v is equal to u plus at, okay, so let's say we're not sure on the velocity, but we know that it starts off with 2I plus 5j. That's the initial velocity, and it has an acceleration of I plus 3j and times t. Okay, so from this v equals u plus at, we can get an expression for the velocity at any time. Okay, we can get an expression for the velocity at any time. So let's just do that. All I'm going to do is, you've seen me do this before in the mechanics videos, is I'm going to multiply out this and get all my i's together and all my j's together. Okay, so I'm going to multiply that out, so I get 2i plus 5j plus ti plus 3tj. Okay, and hang on a minute, have I done this right? Oops, no, I've not. Okay, it's minus 5j, isn't it? So I've got to be careful here. Let's put that in there. Okay. So I've multiplied this out. Now I'm going to get all my i's together. So I've got 2i plus ti, and I get all my j's together. So I've got minus 5j plus 3tj. Now if I factorise it for t, I get, no, if I factorise it for I get 2 plus ti plus, and if I factorise it for j, I get minus 5 plus 3t. Of course, I could write that the other way around, couldn't I, j? So now I've got the velocity in terms of I and j again. Just, it's just in terms of I and j, but I and j are expressions in terms of t. And of course, that p is moving parallel to I. If it's moving parallel to I, there's the I-axis, then of course it's along I, and there's no j. In other words, the j value, it's the time when the j value is 0. Okay, so in other words, it's when minus 5 plus 3t must be equal to 0. So solving that, you can see that we get t is equal to 5/3 seconds. Okay, just checking my screen that fits on, and it just does. Alright, okay, and that sort of thing needs sort of experience and practice. Okay, hope that one makes sense. Okay, so let's rub that out. Let's have a look at this next one. I do like these ones. Whoops. Okay, so really important this to draw a diagram. So a car of mass 800 pulls a trailer of 200. So good at my art. Should have done art at university. Oh wow, unbelievable, brilliant. There we go. Okay, so a car of mass 800. So let's put those in. That's 800 kilograms, and that is 200 kilograms. And let's use some different colours. Yeah, let's make this really good fun. Okay, get those out. Put those there. And it's going along a road, and it's got a tow bar, and resistances to motion for the car and the trailer are 400 and 200. So let's put those on in a different colour. So the car has 400 newtons holding it back, and the trailer has 200 newtons. This will be friction, air resistance, and so on if the wheels aren't oiled enough and so on, and that. So 400 newtons and 200 newtons resisting it. and it says that the engine produces a magnitude of 1200 newtons pulling it. Okay, so there we go, we've got all of our forces on. It's got a tow bar between it. Okay, so let's put, remember that that's because it's pulling it, that's going to be in tension, and tension acts away from the objects, so the tension is acting away from the trailer when we consider it separately, and away from the car. You know, it's pulling, you know, the car is dragging it, so it's pulling it that way, but it's actually the tension, not the engine power, that's pulling the trailer. So the tensions are in there. We need those in for later. Okay. Find the acceleration of the car and the trailer. Well, the acceleration of the car and the trailer, of course, is the same. And so what we're going to do is we're going to ignore that middle bit, because we're going to treat this as a whole thing, okay, as just one object. And we're going to apply F equals ma to find that acceleration. The force, the net force, is the 1200 pulling it that way, minus any resistant forces that way. So you've got 400 plus 200. That's the net force that's pulling it. So you can see it's going to be 600 newtons pulling it, isn't it? Because it's 1200 that way, 600 that way, a net pull of 600. And that is equal to the mass, but the mass of the whole thing, which is actually a ton, a metric ton, 1,000 kilograms, times the acceleration. Okay, and so you can see here that that is all 600 is equal to 1,000 a, and divide by 1,000, you can see that the acceleration is 0.6 meters per second squared. All right, so that's how the car and the trailer are accelerating. Now B, the magnitude of the tension. Okay, so we can take either. This is where we, you know, on my connected particles series of lectures and lessons, we can take the car and the trailer separately. In fact, we should take it separately. Now I can take the car, but there's a few more forces in the car. There's 1, 2, 3. There's only 2 forces in the trailer, so I'm going to take the trailer. Okay, if you just take the trailer alone, we now know that the acceleration of that trailer, same as the car, is 0.6 in that direction, meters per second to the minus 2. I've got it there. Okay, and it's being pulled along by a tension of T, the tow bar, and it's got resistance forces of 200, and it weighs, of course, 200. So if we apply F equals ma just to the trailer, the net force pulling it is the tension minus the 200 Newton forces there, okay? And it's equal to the mass times the acceleration, so 200 times by 0.6, okay? And so you can see that the tension is equal to that, 200 times 0.6, which is 120, okay? Plus 200 when we add 200 both sides, so the tension is 320 newtons. Okay, I could have done it with the car, you know, I could have done, if I'd done the car, I'll do it here for you, and it would work out the same. There's the car, we've got 1200 newtons pulling it, just checking that fits in, does it? Yeah, just. We've got 400 acting that way, and we've got the tension acting that way, and it weighs 800, and it's accelerating at 0.6. Okay, so if I apply F equals ma to the car, I've just got more forces to deal with. I've got a 1200 net force minus the tension plus 400, they're acting in the opposite direction, is equal to its mass, 800 times 0.6. Okay, so if I, oops, just dropped my green pen, got it. If I do, first of all, I'm going to do my 6 8 of 48, so that's 480. If I've got 1200, multiply out this bracket, minus t minus 400, so that is 800 minus t is equal to 480, and then t over to that side, the 480 over that side, you can see that I've got 800 minus 480 is equal to the tension, and there it is, 320 newtons, the same. Okay, but less work, always less work looking at the trailers. And then the last one, see the force of the brakes. I think this one is, isn't it? Okay, I'm going to need a little bit more sort of space for this, so if you've got that, I'm going to go now back up to the top there to show you what's happening here. So see, okay, it says the car is moving along the road, the driver sees a hazard ahead, he reduces the force produced by the engine to 0. Let's get rid of that, that's no longer, and applies the brakes. So the brakes are adding a force now to the car, aren't they? And the brakes are acting that way to slow it down. So it was pulling it that way and now they're acting there, and we're going to call that braking force F, and it's acting in that direction. Okay, I could actually in my maths put the force going that way and it would come out the same value, but it would just be a negative value then. Okay, so because it's going in the other direction. So I'm going to put the force acting that way. It says that the resistances to motion are unchanged. The magnitude of the thrust. Now obviously we've gone that the tow bar has gone from being in tension to in thrust. Remember, thrust is the opposite. It's when you're pushing in. So that means that they turn around. Okay. Instead of acting away from the object, they act towards the object. Okay. So the trailer now backing up is when the car is braking, the trailer is pushing up against it. Okay. And the tow bar is pushing that way on the trailer to slow it down. So that's what causes the thrust. It's under compression. So that's happening now. Okay. So what does it say? And it's decelerating. Yeah. So we've got to find this now that makes it decelerate. Okay. And let's put that thrust in because it gives us that, doesn't it? It says that this. Normally you have to work that out, but this one is asking you, it's telling you what it is, and it's asking you to work out the braking force. Okay, so let's consider these separate again. So let's have a look at our trailer. What can we find if we consider that separately? Well, we know that we've got a 200 Newton resistance force acting that way. We know it weighs 200. We don't know the acceleration. The acceleration, though, it's slowing down, so it's going to be a negative number. I'm still putting it that way, but it's going to be a negative number. So the acceleration, we don't know. And we know that the thrust now is acting that way. Okay, 100 newtons, compressing it and slowing it down. So if we apply F equals ma, remember that is our positive direction, which means that the force that way is 0 minus all the forces that way is minus 300, isn't it? So 300 newtons are acting that way. So the overall force, net force, is minus 300. That, the minus is just referring to in that direction, is equal to the mass, which is 200, times the acceleration, a. And if we divide by 200, we get minus 3 over 2, which is, so the acceleration is minus 1.5 meters per second squared. There you go, it's negative, so it's a deceleration, isn't it? Okay, so we've got that. Now if we look at the car, we'll do the car now to find this force. So now that we've got the acceleration or deceleration, my car, draw it again, there's my braking force, 400 that way, pushing, backing up is 100 newtons now, pushing against the car there, and we know that the acceleration is minus 1.5. Notice I put my arrow in that way, the minus means it's going the other way. Okay, so now I'm going to apply F equals ma, so that way is positive. What forces are going that way? The 100 newtons force minus all the forces going that way, and minus the forces going that way are the 400 plus the braking force. Okay, and it's equal to the mass, which is 800 times the acceleration, which is minus 1.5. Okay, so there we go, we've put it in. That minus 1200, multiply this out, 100 minus 400 minus f, be careful there, people just write that down as minus 400 plus f, but it's minus one lot of all of that bracket. So that is minus 300 minus f is equal to minus 1200. Take the f over to that side, plus f to both sides, add 1200 to both sides, and you get now 900 newtons. And it's come out positive because we said it was going in that direction, didn't we? Okay, so it's 900 newtons in that direction. If we'd done it that way, pointing that way, it would have come out as minus 900, because in that direction it's minus is going the other way. So it's a force, that force acting that direction is a force of 900 newtons. Okay, that's that one. Hope that makes sense. Good question, that one. And it's question 6 out of, you know, they usually have 8 or 9 questions on the old M1 exams where we got that one from. And so it's, you know, it's 2/3 the way through. It's getting to a grade B question at AS. And then the last one, it's one of these. I took these because they're not on the old M1 papers. They're new on the syllabus. Then I've taken it from the textbook. Sorry, I copied this bit. It says find an expression for the particle from the distance of the particle from the origin. Obviously, that's probably obvious what that means. Okay, so it's one of these with variable acceleration, and yeah, so it's not equation, it's not Newton's equations, is it? So if you remember, we've just done these S, V and A. We differentiate down, we integrate up, and what have we got? We've got an expression for the velocity, so let's put it in the velocity line, which is 6t minus 2t 3 over 2, and this question actually couldn't be simpler just looking at it, because it's just saying find an expression for the acceleration. Okay, well, the acceleration we differentiate going down, so the acceleration is equal to this differentiated, which just becomes 6 times by the power 3 2's are 6 divided by 2 is 3, so minus 3t, and not 1 off the power, so it's simply that. That's an expression, okay, for the acceleration. Just check that I've done that all right. These earlier, yeah. And then it's the next one. It says find an expression for the displacement. So we just integrate up to get to there. Of course, when we integrate up, we get a constant that we put on the end. But it does say that when t is 0, it's at its origin. In other words, s is 0. So that plus c, when we put t and s is 0 in, is just going to be 0. So all we have to do is integrate that up. So s is equal to, add 1 to the power, so squared, divide by the new power, so that's going to be 3t squared. Add 1 to the power 3 over 2 is 1.5. Add 1 is 2.5, as a top heavy is 5 over 2. So the new power is going to be 5 over 2. And divide by the new power, when we divide by 5 over 2, we invert and multiply, KFC, keep, flip, change. Okay, so invert and multiply, so times by 2/5, and we already have a 2 and minus 2 there. So 2 2's are 4, okay, so 4/5. So let's just, there would be a plus c on the end, but when t is 0, s is 0, so that just cancels that, so c is 0, so s is equal to 3t squared minus 2 2's are 4, 4/5 t to the 5 over 2. There we go, and that's that integrated to that. And that's it. That's for this week. Hope that all makes sense. Oh, and hope you enjoyed the pounds as well as that one. Beautiful, beautiful.